Weather forecasting is very important in today's society. One reason on why it's so important is that it helps save lives. It warns people of natural disasters such as hurricanes, tornadoes, severe thunderstorms, etc. For example, people who live near the water need to know if there's a hurricane coming towards them in advance so they can prepare for it and evacuate. Weather forecasting can predict when those natural disasters are imminent. The more warning people have, the better they can prepare and the least likely they are to die due to such natural disasters. It can also tell you what weather you have coming within the next 5 to 7 days so you can plan accordingly. One person had a huge impact on United States history when he invented the Doppler radar, and this person is Christian Andreas Doppler. Christian Doppler was an Austrian physicist who first described how the observed frequency of light and sound waves is affected by the relative motion of the source and the detector. This phenomenon became known as the Doppler effect, which Christian Doppler is most known for. In 1842, he published Concerning the Colored Light of Double Stars, which contained his first statement of the Doppler effect. He theorized that since the pitch of sound from a moving source varies for a stationary observer, the color of the light from a star should alter, according to the star's velocity relative to Earth. Doppler radar systems were first developed just after the Second World War. Radar operators noticed that weather conditions such as rain, sleet, and snow caused quote-unquote noise to appear in the radar signal. Doppler radar is based on the Doppler effect, which is a shift in the frequency of a wave when the source is in motion. With Doppler radar, a microwave pulse is transmitted. Motion from wind and weather causes the microwave pulse to echo back at a different frequency. By using computers to analyze the echo, we can calculate the type, intensity, speed, and direction of the weather. This is used heavily in storm tracking. A radar unit consists of a transmitter and a receiver. The transmitter emits pulses of microwaves, a type of radio waves, outward in a circular pattern. Precipitation scatters these microwaves, sending some energy back to the transmitter, where it is detected by the radar's receiver. The intensity of this received signal, called the radar echo, indicates the intensity of the precipitation. Measuring the time it takes for the radio wave to leave the radar and return tells us how distant the storm is. Uniquely, Doppler radar can measure wind speed in precipitating regions. A Doppler radar receiver hears waves of a higher frequency if precipitation particles are moving toward the radar, and a lower frequency if particles are moving away. This allows Doppler radars to identify severe weather. Hundreds and hundreds of years ago, there were no weather stations, and people could not go on the internet to see what the forecast was going to be. As it turns out, they did the best they could to predict the weather through visual observations like cloud patterns, location of stars and planets, phases of the moon, and movement of winds. But today, we no longer have to guess with the weather. We have the Doppler radar that Christian Andreas Doppler invented, and it changed the world in the sense of weather forecasting.